Hi, everybody. We're going to be doing P.10, which is in the sequence and series part. And we're going to be converting recursive formulas to explicit formulas. This is going to be a very challenging thing to explain, but I'm going to do my best. I actually had to preview it myself, so that's how hard it is. I found it to be somewhat challenging. There's a bunch of things we could do here, and I think in order to explain it, I'm going to go ahead and write some terms down. My very first term is negative 17. So I'm going to write it out, negative 17. And each time this recursive formula is telling me to get to the next term, you take the term that came before and you add 17. So I'm going to add 17 to that. And I'm going to get, I hope you can, 13, sorry. It says 13. I don't know where I got 17 from. I'm going to add 13, and I'm going to be at negative 4. And then I'm going to add 13 again, and I'm going to be at 9. And this is going to be my sequence, and I'm going to add 13 again. I'm going to be at 22, and so on. Now, these represent points, and one of the things we want to think about is that our input is the integers. Well, actually, the natural numbers. 1 goes to negative 17, doesn't it? And 2 goes to negative 4. And 3 for n gives us a 9, and a 4, or the fourth term, gives us a 22. Some of you that are familiar with points know that in order to get a set of points like these, we could write it in terms of y equals mx plus b. And that's kind of what we do when we write an explicit formula. The trick here is to recognize that 13 is the slope. And there's lots of ways of thinking about that. Notice that from, I'll do it on this, I'm going to do it with this pair because it's probably the more obvious for you. Notice from 9 to 22, I went up 13. That's the change in y over the change in x, which is up 1. So my slope is 13 over 1. And hopefully you can see that this common difference is always going to work out like that. If you want to see subtracting, it's 22 minus 9 is 13 over 4 minus 3 is 1. That's going to give you your slope. Well, we're almost done. If I want y equals mx plus b, and notice that we're not really using an x, we're using an n. So I know in this particular sequence that the a of n, remember that's our output, that's our y value. Our input is the n. Our m, our slope is 13, and x, the input is n, and we need one more thing. We need the 0 term. Remember that the b is what happens when we put in 0. Well, look at these. Do you see what's missing? I need to know the term that came before because I need that 0 term in order to do this. Now, there's a bunch of different ways of getting there, but I just want you to think about how could I get back one term? Well, I have to do the opposite. Whatever I'm doing, I'm adding 13 each time. So in order to get back one term, I need to subtract 13. And I'm going backwards. So that's going to give me negative 30. And that's going to be, minus 30. And the way you can test this is you can say, well, we know what a to the 1 is, don't we? Or a1. So we know the first term is negative 17. So if I put a 1 in for n, I should get negative 17, and I do. Notice the common difference is my slope, and the 0 term is my b. So there it is. I hope that's clear. I'm going to be going much faster on the future ones so that you can see them. And then we have the minus 30. Okay. Now there are geometric sequences as well. All right, so now our first term is negative 25, and our common difference is 9. So we're adding 9, and I get to negative 16, and then I get to negative 7, and so on. Now I need to know the original term, And because this is adding 9, in order to go back one term, I have to subtract 9. And negative 25 minus 9 is negative 34. If you're not sure, you could grab a calculator, I suppose, and do it that way. I hope you wouldn't have to, though, and I really want you to practice your integers so that you'll be a little more adept at it. So here's our 0 term. That's what we're going to be adding. Now, remember that this common difference is our slope. So I'm talking about 9n minus 34. And if you want to check your first term, I'm going to do it one more time. I'm going to put a 1 in for n. That's 9 times 1 minus 34 should give me my first term, which is negative 25. And that is correct. This is where we have a little issue. Notice that the term before is the same as the term after. Well, let's write some of them down, and I think you're going to see what's going to happen here. This is called a constant function where nothing is changing. And you're going to be very tempted to write a to the n equals n. But a constant function is not y equals x. It is y equals this number, whatever it happens to be. So 8 over 11 is also our 0 term, isn't it? You see what I mean? This is our 0 term. And so we're talking about 0n plus 8 over 11 because the difference is 0 every time. That's another way of thinking about it. Anyway, it's just 8 over 11. And that's it, because it's going to give us 8 over 11 every time we do it. That's the explicit formula. All right, our first term is negative 31. Our common difference is minus 5, so I went to negative 36 and negative 41 and so on. And to get back 1, I have to add 5 to get to my 0 term. So I'm at negative 26 is my 0 term. My common difference is minus 5, minus 5, minus 5, and that's my slope. So I have negative 5 and minus 26. I really hope I explained it well enough for you. There are other ways of looking at this, and I mean, we could use a calculator hack or something, but I think that this makes it the easiest. Now, this is the case where they're the same, 65, 65, 65, with 0 change. There's no change, so it's a constant function. That's what we call this thing. And it just always gives us 65. Okay, let's see. What do we got here? We have a constant change of negative 5, and I'm gonna shortcut it a little bit. I'm gonna go a little faster now. So I'm gonna put in my negative 5n because negative 5 is my change, isn't it? It's going down 5 every time, down 5, down 5, down 5. The negative 28 is my first term. So to get back to my term before that, I have to add 5, which is negative 23. And I'm done. That's it. And you can test it. If I put a 1 in for n, I get negative 28. This one, constant function, just giving us over and over again, the negative 77. Oh my God, this thing is still doing this. Sorry, it's my Zoom meetings. I've got to really turn them off somehow. All right, so we've got a to the n is just negative 77. That's it. That's all there is to it. In this one, a to the n is equal to this term before, which is negative 61. And it's not changing. It's a constant function. They're probably going to give us a geometric pretty soon. There it is. Now this time it's a geometric sequence. And remember that we're multiplying by 5 every time. And so my first term is negative 300. And I'm going to multiply by 5. I'm not going to add 5. I'm going to multiply. That gives me negative 1500. And if I multiply by 5 again, I'm going to get negative 7500. And if I multiply by 5 again, what am I going to get? 37.5? I think so. Negative 37,500, and so on. We could keep going and multiplying by 5, but the whole point is that it's a geometric sequence. And in order to write the geometric sequence, notice that I'm multiplying 5 times 5 times 5 times 5, and there are literally 4 of them in the 4th term. I hope that makes it clearer why I'm going to do the following. I am going to take 5 to the n power, because notice I'm multiplying by 5 one time to get to here. Well, actually, 2 times to get to this 2nd term. Again, I have to do the opposite to get back to my 0 term. And my 0 term is what goes here. Because we always start by multiplying, because our first term is 1n, and n is 1. That means that whatever I have here is going to be multiplied by 5 to get my first term. So to get my 0 term, I have to do the opposite, which is divide by 5, and that is negative 60, isn't it? All I did was take negative 300 and divide it by 5. And in order to test this theory that I have, that this is actually the geometric series, it's real easy. We just say if a to the n is equal to that, and I know what a1 is, then I could put the 1 in, couldn't I? And that is going to be negative 60 times 5 to the 1. That's where that 1 came from. And that is going to be negative 300, which I can see is correct. And if I want the next one, I want to show you this. To get to the next one, it's going to be 2 of them, isn't it? Which is going to put me right here. And then the next one is going to be 3 of them, and so on. Hopefully that's clear. It's going to be negative 60. Notice the signs aren't changing. I could probably get away with times, but for me, I like the parentheses, but I'm going to try the times. I want 5 raised to the n, and that should do it. Normally I put it in parentheses, but I think that's just fine. I hope it likes it. It does. Okay. I usually put parentheses around it. Anyway, this is a constant function. Nothing exciting here, 16 over 77. Don't panic when you see the fraction, because it's a constant function. It's the easiest kind. Okay, this time our common difference, remember, is our slope. So our slope is negative 19. You can put it in, negative 19, and then we have to add our initial term. Well, notice something interesting. I have negative 18, and then I'm going to go down 19. That's going to be negative 37. Then I'm going to go down 19 again, and so on. But to get back 1, I have to add 19. So that's going to be 1. So that if I subtract 19, I get my first term. So I have plus 1. Hopefully that's clear. Again, I could put the 1 in and get negative 19 times 1 plus 1, which would give me my negative 18, wouldn't it? There it is. Okay, constant function. I'm hoping you'll begin to like these. They're pretty easy. I like those constant functions. Okay, the common difference is minus 1. So we're going down 1, down 1, down 1, down 1. And in fact, a good way to think of it is the slope says take your output, go down 1 and over 1, which is really what's happening on these guys. So there is a connection between linear equations and sequence, explicit formulas. So we have negative 1. I don't have to put the negative 1. I could have just put negative n, but I'm going to go ahead and write it like that. And the opposite of going down 1, remember I'm going down 1 to negative 40. I'm going down 1 to negative 41. Oh man, this is messy. To negative 42. I'm going down 1 every time. So obviously my first term was negative 38. And I got that by adding 1. I have to do the opposite. And of course, if I put a 1 in there, I get my negative 39. Oh, we have a geometric sequence starting with 4. So 4, and then we multiply by 4, which gives us 16. And then we multiply by 4, which is 64. And then we multiply by 4, and we get 256. Is that right? Yep. And we multiply by 4, and we get 1024, and so on. But we need to know the 0 term because that's our real multiplier. That's going to be the 1 because I have to divide by 4 to get it. So I'm talking about 1 times 4 to the n power. And that's going to be my first term. If I put a 1 in there, take a look. If I put a 2 in there, if I put a 3 in there, 4 to the third is 64. I don't have to write the 1. I could just write 4 to the n, but I think I'm going to put the 1 because that's generally how it looks. There it is, 1 times 4 to the n. I don't think they're going to count it a problem if you put a 1 in there. Oh, a constant function. I'll bet you know the answer to this one. We like those. And we're getting there. And, oh, a geometric sequence. Remember, we're multiplying by 2. So we're starting at -1. And here's where a lot of people have a lot of trouble. So it's going to be -2, isn't it? And then we're going to multiply by 2 again, and we're going to get -4. And we're going to multiply by 2 again. We're going to get our -8, and so on. Now we have to go backwards to get to the first one, which is -1/2. I had to divide by 2, didn't I, to go backwards. -1/2 times 2. And if I go the right direction or the positive direction, it is going to work. So my 0 term is -1/2, and I'm multiplying that by my 2 to the n power. Hopefully everything's clear. I don't think you need to put I don't think you can put a decimal there. I mean, I suppose you could, but I don't think I think they prefer that you put the fraction. Let me get rid of that. I have a times. Be careful you don't put it in the denominator. And then I've got 2 raised to the n power. Like I said, I normally put parentheses around my 2, but it's fine. It should work fine that way. Because remember, order of operations, exponents come first. All right, looks like we have a common difference of -13. That's our slope. I hope you didn't forget, that's times n. And our initial first term is 15. I got to write, there we go. Our initial term was 15. Our next term is going to be 2. Our next term is going to be -11. We're going down 13 every time, aren't we? Well, in order to get to the term before that, you have to add 13, which would be 28. So plus 28. And you can check your first term by putting a 1 in for n and yada, yada, yada. Looks like we have a geometric sequence. Now, what's interesting about this particular geometric sequence is that we're multiplying by -3 every time. And this time you must put it in parentheses. I know that sounds weird, but it's really important because this is not the same as this. These are not equal. You see, if I take this side to an even power, it gives me a positive. But no matter what I do, this one is going to be negative. And here's the reason. I know you probably don't care, but here's why it works that way. You see, you have to do the exponent first, and then you deal with the -1. In this one, the -1 times 3 is the -3, but notice it's inside the parentheses, and it's more important than the exponent. So that's why I was putting parentheses before, and it is important. So anyway, we've got 9, and then we're going to alternate -27 because we're multiplying by -3 every time. And then we're going to multiply by -3. I don't know why I didn't put my negative in there. Again, we're going to get 81, and then we're going to multiply by -3, and we're going to get our -243, and so on. In order to get to the initial term, I have to go backwards, which is dividing by -3, and I know that it was -3. And then when I multiply it, I get the +9. Anyway, there it is. So my initial term is -3, which is kind of weird. And it is important that you put this -3 inside parentheses. Weird, huh? Be careful. Without the parentheses, it would probably be wrong. Okay, trust me. -3 times parentheses -3. I'll take it out. Come on, raise to the n. And I'll erase this so you can see it without my little dots on there. See it there? Be careful. And a lot of people would wonder what happened if they didn't put the parenthesis. And they'd go, what happened? Okay. What kind? The constant function? And oh man, they're being nice to us. It's the $2 store now. Hopefully you know what I mean by that. The dollar store is a constant function. The price is always 1, 1, 1, 1. Anyway, okay, so our difference is 4. That's going to be our slope. We're going to start at 41. Let's get him in there. 41, and our constant difference is 4, so we go to 45, and then to 49, and yada, yada, yada. And our initial term must have been 37. We have to go back 4 to get to it. So there's our 0 term, and we're talking about 4n plus 37. And I am actually going to check it because it is my last one. And in order to check it, I just say A1 must be equal to 4 times 1 plus 37, which is 41. And there it is, with a common difference of 4. I hope you guys got it and it makes sense to you. Go all the way to mastery, and I know you can do it. Bye, everybody.